So, hi class, welcome back to our module number 4 part 2 video. So for this video, we'll be solving problems, okay? So from your module, you have your problem number 1. The simply supported beam carries a concentrated load of 14 kilonewton and a concentrated load of 28 kilonewton. So derive the expressions for shear force and the bending moment for each segment. So for each segment, we are going to derive the expressions. Then, for number 2, draw the shear force and the bending moment diagrams. Neglect the weight of the beam. So for this problem, they already solved the book already gave us the value for RA and RD. So at A, we have a pin support. Then at B, we have a roller support. Okay? So in order to solve for the expression, we are going to divide our segment into three. Our structure into three segments. Okay. So we have segment. Okay, segment AB. So segment AB is from a distance of x. Take note, this is our x-axis. So x from 0 to distance, that is 2 meters. So this is 2 meters, 3 meters, and 2 meters. So from 0 to, no, baliktad. It should be this way. Okay, so that is segment AB. So we're drawing the free body diagram. If I am to cut that section from point A to a point before point B, okay, magiging itsura niyan is ganito. Okay, so this is my cut. So let's say this is plane A prime. So this is A prime, A prime. Okay, and this is our distance x. And we know if we are to cut our section, we will be having a shear force. Okay, so my reaction is upwards. So if I am to use the equilibrium, which is summation of forces for vertical, I can observe, and by observation, that the shear force will be downwards. And I will assume that the moment is clockwise. So this is the shear force AB, and this is moment AB. Okay? And I will designate this as point E. Okay? So the next thing we need to do is the summation of forces. Summation of forces vertical is equivalent to 0. All forces that are pointing upward should be positive. So I have here RA. RA is 18 kilonewtons. So positive 18 minus shear AB is equivalent to 0 because there are no other vertical forces present. So we have there shear AB is equivalent to 18 kilonewtons. So our assumed direction for AB is downward, that is correct. And the magnitude is 18 kilonewtons. Now, for the what do you call this? For the moment. So for the moment, I'll be having my summation of moment at point E. Okay, at this point where my cutting plane is. And that is equivalent to 0. All forces rotating clockwise should be positive because I am assigning that all forces rotating clockwise are positive. So I have here moment AB. Then what other force do we have? Shear AB will not is at the point of reference for rotation, so that is 0. Then we have RA. RA will also be rotating in a clockwise manner, so that is plus 18 kilonewton times a distance of x, and that is equivalent to 0. Therefore, MAB is equivalent to negative 18x. Therefore, since that is negative, therefore my assumed direction is my assumed direction is incorrect. So that is 18x counterclockwise. Okay? Next, I'm going to consider segment BC. Okay, so segment BC. So that is from 2 to 5. Okay, so from 2 to 5. But please be careful, because even though I am considering a segment 2 to 5, I will still be starting at the start. So from this point up to this point, okay? Any point before C for segment BC. Okay? So for that, I'll be redrawing the free body diagram, the FBD. So I have here 14 kilonewtons. We have 2 meters. Then I have here my cutting plane, and I assign this as F, point F. So again, I'll assure my shear diagram, which is positive, to be downwards. Then let's try moment from our convention. If you can recall from our first video, positive. So yeah, so we have here counter clockwise. So yun yung gagamitin natin. I repeat, these are conventions, and it doesn't mean naman na pag ginamit mo is counterclockwise or clockwise, mali ka na. It will still give you the same answer but different magnitude. So you can still correct it naman in terms of the direction of your moment. Okay, so let's say this is, we have here shear BC. Then we have here moment BC. Then I have here 18 kilonewtons. Now, for shear, it is summation of forces. Summation of forces vertical is equivalent to 0. All forces that are pointing upward should be positive. So I have here positive 18 minus 14 minus shear BC, and that is equivalent to 0. 18 minus 14 is equivalent to 4. Transpose it to the other side of the equation to make it negative. Magka-cancel yung negative. Therefore, shear BC is equivalent to 4 kilonewtons. Okay? Next would be the moment. Now, for the moment, summation of moment at point F is equivalent to 0. All forces rotating clockwise should be positive. So what are the forces that are going to rotate with respect to F? So you have 18. 18 at a distance of, this time, this would be my x distance. Okay? So this is x. So 18 times a distance of x minus 14 at a distance of x. This is x minus 2. Bakit naging minus 2? Take note, this is x, then this is a distance of 2. So that would be x minus 2. So x minus 2. Then I have negative MBC is equivalent to 0. So I'll be transposing moment BC at the other side of the equation to make it positive. So that is equivalent to 18x minus 14x minus 2. So this is the expression for moment BC. Okay. Next would be segment CD. Okay. So for segment BC, so no, sorry, segment CD, the distance x that we're going to consider is from 5 to 7. Okay, so redrawing the free body diagram, we will be having 18 kilonewtons, 14 kilonewtons, and we have 28 kilonewtons, 2 meters, 3 meters, and that is our cutting plane. Okay? So, sabihin natin this is B prime plane. This is C prime, C prime. So, this is cutting plane, C prime. Okay? Okay, so let us now generate our shear formula. So, shear is summation of forces vertical is equivalent to 0. Sabihin natin this is point, we have, that is point F, G. So, let's say this is G. So, we have shear CD. Then we have moment CD. Okay, so all forces pointing upward should be positive. So, we have positive 18 minus 14 minus 28 minus shear CD is equivalent to 0. 18 minus 14, that is positive 4, plus, minus 28, that is negative 24. Transpose it to the other side of the equation. Magiging positive siya. So, shear CD is equivalent to negative 24. Okay? So, that is equivalent to 24 kilonewton and it is pointing upward. So, our assumed direction is incorrect. It is pointing upwards. Next, for the moment, summation of moment at point G is equivalent to 0. All forces that are rotating clockwise should be positive. So, for the positive, take note, ang lever arm natin, still this is x. This is distance x. Then this point is x minus 2. This is a distance of 2. Then for this one, it is x minus 5. Okay? Because this is still distance, x minus 5. Okay? So we have 18 times x minus 14 times x minus 2 minus 28 times x minus 5 minus moment CD is equivalent to 0. Transpose MCD to the other side of the equation to make it positive. So our expression would be 18x minus 14 x minus 2 minus 28 x minus 5. Okay? So that is our expression for moment at section or segment CD. Now, how are we going to draw our moment diagram? By the way, there is a question. What if I am going to consider the other side of my figure? So, kasi if this is your figure, parang, sir, mas madali naman if manggagaling ako from right to left. So, that will still be the same. Segment CD from right support, segment CD, and you have a limit of 5 still to 7. Then I'll be drawing my free body diagram. It will still be the same. It should be the same. I should be generating the same answer. So I have here 24. Then my cutting plane is here. That is C prime, C prime. So shear would be downwards. And moment, I'll assume it to be negative. Clockwise rather. So this is M CD. Okay. So having that, Summation of forces vertical is equivalent to 0. All forces pointing upward should be positive. So I have 24 minus shear CD is equivalent to 0. So shear CD is equivalent to 24 kilonewtons. So they are the same. Okay. Okay, so continuing, we have summation of moment at point G is equivalent to 0. All forces rotating clockwise should be positive. So we have here positive MCD minus 24. This time, ito naman yung distance, X. So times a distance of X is equivalent to 0. So MCD is equivalent to 24x. By the way, mali ito. This should not be 5 to 7. It should be from 0 to 2. I repeat, it should be from 0 to 2. Okay? 0 to 2 yung limits natin. Okay. Mamaya, makikita natin if this expression here is the same as the expression here using these limits and these limits. Okay, so now we're ready to plot our shear and moment diagram. Okay, so we have the reaction at A, which is equivalent to 18. So we have here 18, so this is 18 kilonewtons. Then for here, how are we going to draw the shear diagram? So we all know that the derivative of the shear with respect to x, or it is simply the slope of the shear diagram, is equivalent to negative W. What is negative W? It is negative of the load. Okay? But do we have a distributed force along segment AB? So that is equivalent to 0. Therefore, the change in the slope is equivalent to the integral of 0 dx. Therefore, the shear is equivalent to the change in the slope is 0. So that is a straight line going to segment or point B. Now from point B, we have here, or we can simply follow our equation. Where is our equation? Segment. Okay, so from there, it is positive 18. So this is 18. And from our computed value, we have a shear BC, which is 4 kilonewton. So from 10, it will go down to 4. Okay, bababa siya sa 4 kilonewton. Okay. Now, the change in slope with the change of the shear with respect to x is equivalent to negative W. Okay. But W, but do we have a W between segment B to C? We don't have. Therefore, the slope from segment B to C is equivalent to 0. So that is still a straight line. Okay, so that is a straight line. Then from our computed values, segment BC, we have, no. So segment AB, let me correct that. Segment AB is 18 kilonewton, which is correct. Straight line siya. But the slope is 0, so that is straight line. So we satisfied our equation. The shear from A to B is 18. I repeat, 18. Then ang slope natin is 0. So straight line. Then we have here segment BC. Ang slope, ang shear natin is 4. So hindi nagkaroon ng additional changes ng load from segment B to C. So straight line na 4 and ang slope natin is 0. Take note, bakit straight line? Kasi take note, we have here our axis which is x. So the derivative with respect to x is 0. So 0 straight line, 0 slope. Okay? Next, we have segment CD. So segment CD, we have 24 kilonewtons. But take note, we have a point load here of 28 newtons. So we will be having a downward of negative 24. Bakit? 28, a positive 4. So this is 4 minus 28 because that is pointing downward. So this is negative 24. So the shear CD is negative 24. So diretso lang yan. Straight line. Is it a straight line? Let's check. The change in the slope with respect to x is equivalent to 0. Bakit? Is there any change of loading from this point to this point? Wala. So that is 0. And lastly, we have a force upwards of 24 kilonewtons. So that will go back to 0. And that is your shear diagram. Okay? So if ginamit naman natin itong isa, we have here shear CD that is pointing downwards. Take note, tama rin naman. We have here 24 downwards, then a reaction of 24 going up. So tama yung if we are still going to have our reference with respect to the right support. We will continue the moment in the part 3 of our video lecture.